Okay.
Okay. Well, good afternoon, everyone. This is a presentation that we were going to give to blueberry growers last year, and we couldn't because of this past year, I should say, because of the pandemic. We did do this earlier in the week for blueberry growers, but it's something that really applies to all operations, and we want to, especially for leafy green growers. We're going to talk a little bit about what is backflow prevention, how it fits into the Food Safety Modernization Act, the produce safety rule, because there are sections in there which apply. We'll look at some of the equipment and some examples. We'll start out talking about what is backflow, why prevent it, and how to prevent it. So fluid mechanics, it's very obvious the water flows downhill. We have enough gravity that keeps it doing that way. It can go sideways. It really goes by the path of least resistance. And we use pumps to create pressure because water will go from a high pressure to a lower pressure, and that's really how we get irrigation. The pipes, tubing, depending on, again, diameter, the material, the compatibility of material, how it affects the flow and backflow in some cases. And also we can obviously stop the flow by using valves, but that really doesn't help us with backflow prevention because you're never going to be there every time to turn that valve off and on. So what is backflow? Well, it's moving the water in the wrong direction or going where it's not intended to go. And we need to develop different ways to how to stop that going in the wrong direction and to reduce the cross-contamination or cross-connection. In the east, we don't have much of a problem with cross-connection. Out west, it is a problem where you have feedlots and they are injecting into the irrigation lines and spreading on the field and then turn around and irrigating using the same material. And this has been a problem in parts of California. There are three parts in the PSR, the produce safety rule, that relates to backflow. And the biggest thing is that in the rule, it says that we need to ensure agricultural water is safe and of adequate sanitary quality. So I'm going to talk about these three sections in the rule. The first is 112.41, what requirements apply for the quality of agricultural water. As I said before, it's agricultural water must be safe and adequate sanitary quality for intended use. That doesn't mean that, for instance, the water that you irrigate with is the same quality of the water you would use to wash off packing equipment, washers, or any type of harvest or post-harvest activity. For irrigation water right now, the standard is 126 colony forming units, or most probable number per 100 mils of water. So you're allowed to have some generic E. coli in that water. For harvest and post-harvest, we're talking about non-detectable generic E. coli. And again, this is water that you're using on hard surfaces. It's not drinking water, but it is a standard for harvest and post-harvest use. And it's the same water that you'd be applying to for the product, for instance, whether it's cranberries, blueberries. Well, you wouldn't be putting on blueberries, but on leafy greens, for instance. So there is a difference about the definition of water in that case. When we look at 112.42, there's a whole bunch of different parts here. We're talking about the water source, we're talking about the distribution, we're talking about pooling of water. And that last one is really one of the most important ones. The first part of this is A5. It says there, it's looking at, if you're using surface water, where that water is coming from. What's the possibility, for instance, from someone upstream, you have a contamination issue, and you're turning around and using that water directly on the harvestable part of a crop. The example that I've dealt with in the past, a vegetable operation growing fresh vegetables, and they have a dairy farm above them, and they're using surface water for some of their irrigation. And that dairy farm, the cows have access to the stream. And this has been an ongoing issue with that grower, because we know there's problems with water supply in that case. The second part of this is to prevent the water distribution system from being a source of contamination for the produce, for food contact surfaces. So looking at how the water is being distributed, the chance of leaks, chance of contamination. Again, it could be an open water source such as a pond with wildlife. It could be a poor underground main, for instance. I've worked with a grower in the past who had old underground main, and we were trying to use a chlorine, calcium hypochlorite to sanitize the underground main. And it took us about 2 weeks before we were able to remove all the stuff that had built up in that line. So he had lots of algae in the line because it had been there for so long, but we eventually did get it cleaned up. The third part there is, it says the control of cross connections, and I already mentioned that a little bit earlier. The last one is where we do have some issue with some operations where there is water pools at the end of, say, an elbow or a deadhead, and pressure is released. It's irrigating, and you pressure release water coming out of that because of slope or whatever. And then when you turn that system back on, that water gets sucked into the system or runs in by gravity before it's turned on. And you can be contaminating the harvestable part of the crop because of that pooled water. So that's the type of things you need to think about there. Whether it's an elbow, whether it's a deadhead, how much water is pooling there. If that is an issue, then try to find a way to keep that connection out of the water. I mean, whether you're digging a little area where the water flows away from that elbow, or however you keep it from running back into the pipe. The third part is 112.133, and this is related to the backflow. Making sure the distribution system, there's enough pressure that you don't have a problem with the sanitation, making sure there's not an issue with sewage or liquid waste. But the main thing is the backflow prevention, how you can stop a contaminated source going back into a good water source. And that's what we're really going to talk about. If anyone has any questions, please, you can unmute yourself. We have a small group, so we can definitely have a conversation. First thing to do is, and we've talked about this with audits, and also it does relate to the PSR, is to map your water sources. In this case, the example here is Google Maps. You can use FSA maps, you can use hand-drawn maps. There's no one way to do it, but making sure you know where your water source is. In this case down here, they're using a spring, and this is their pumping station. And this is their overhead with their risers. They have a well here, which goes to the house. This is their septic system. And they have another building, again, where another septic systems. This is where their drip is. So something simple so you know where they are. This is something, especially with an audit, that the auditor would ask for. The other thing, when we're talking about groundwater, and we're talking about wells, making sure that well is constructed properly, making sure that soil slopes away from that wellhead, to make sure that there is nothing that will run down the outside of that well. And we used to have, and we still have, some pit wells in southern New Jersey. And if they do not have a good cover over them, a good shed over them, those pits can fill up with water at times, and that water can run down on the inside of, on the outside of those pipes, and end up contaminating the water source. Making sure that that pump is working correctly. Again, no leaks. With the well, you should have very few problems unless that well is cracked somehow, or again, is sloped the wrong way. and you need to have a backflow prevention device on it. In New Jersey, those are required for all water sources. This is just 2 examples of backflow devices. The one on your right there, excuse me, the one on the right is for in a building type situation. The one on the left is irrigation. Something that has come up recently or over the last year is how do you test these? Some growers in their packing operations have plumber come in and certify that they're working properly. I've talked to irrigation people and I generally get no response on how they're checked as far as irrigation is concerned. So I know some of the irrigation people are now talking to the manufacturers to make sure that they do understand how they're supposed to be serviced and how they're supposed to be tested. As far as disposing of water, you look at on the right there, you'll notice that it's a small hand system with a bucket where the water is collected. If you have for instance, a portable john and a wash station connected to it, that can be, wastewater can either go into the porta-john, depending how it's piped, or collected in another container, but because it must be collected and taken out of the field. I several times get the question about, well, what do I do with it? I got a bucket full of water from washing your hands. What do I do with it? You can dump it in a fence row, for instance. Biggest thing is you don't want it so it's running into the field and touching the harvestable part of the crop, or someone walking through where it was dumped out, or someone driving through was dumped out. So just think about a good place to get rid of that water. I mean, obviously, if you're close to a drain, you can pour it down the drain, but there are other options. Now, talking a little bit about backflow devices, we're generally talking about 2 types. The one is one flow type, which stops the flow of water, and we'll go into more of that in a minute. And the other one is to an easy flow path, which is an air gap. And I'll show you some examples of that and some situations. Air gaps are great for like pesticide filling. What you don't want to do, and which I do see every once in a while, are people putting a hose inside a tank to fill their pesticide tank, and then leaving a stick in there, it goes to the top or overflows, and they may have already put the pesticide in there. Then they take that hose and throw it on the ground, and not having a backflow device on the system. That's a great way you can contaminate a well. So check valves, 2 main types, the swing type, and I'm showing you examples of that, which just has a gate inside it to keep the backflow from happening, and the spring type, which is as it implies, it is a spring to keep it from opening or closing. There are advantages and disadvantages to each of these. This just shows you the example of the spring ball type, where when it's closed, the spring is holding the ball against the metal on each side, so the water can't flow. And then when you turn the water on, the pressure opens that ball. The same thing with the spring disc type. You have a spring that holds it against some type of a structure, and when the water goes through it, it opens. Then you have the gate type, which is hinged on the top, where again, it's open with the water pressure. And water pressure goes down, it closes, stopping from anything going back into the line. So these are examples of spring ball types. They come in several different dimensions. All these come in several different dimensions, depending on what your system is. The swing gates and all the spring disc type. So these are just some examples. And then a foot valve, which I'll talk about in a minute. So this is a spring check valve type. They are usually labeled, or should be labeled, with which way these get installed, because they do need to be installed properly. And they all have on them which way the water flow is. You obviously do not want to installed them in the wrong direction. You'll notice here on the right, there's the hinge on top and the gate, which opens when water pressure goes against it. So this shows the example. Again, on the left, you have the no water pressure on it. In the center, as you put the water pressure, that gate opens upward. And on the right is an incorrect installation, where in this case, it was installed upside down. So that gate is always open, which gives you no control for backflow. Foot valves are mainly for maintaining prime on a pump. And again, you can see which way they have arrows showing them which way they need to be installed. And that's the main purpose of them. They have a screen on the bottom, which can be cleaned if necessary. And these are mainly on wells. So there are 5 key points about check valves. What's the intended use of it? Think about how big your system is. Think about where you should be putting them, making sure that they're the right size and will do the job for what you want. There's differences between the swing and the spring type. Then there's a good video, YouTube video, which Jen is putting this YouTube address in the chat box for people to, if they want to look at it. And the biggest thing, the difference between the two is, again, with the swing type, you have to install them properly. The wrong way, again, that gate will always stay open. With the spring type, it doesn't matter which way you install them. You can install them vertically, horizontally, it doesn't matter, because you're relying on that spring to open and close the valves. Material compatibility, for the most part, everything will work with water. One concern is if you're using peroxyacetic acid, PAA, or chlorine type product, as long as you have lower concentrations. For PAA, it's between 24 and 80 parts per million. And with a chlorine type material, 25 parts per million, you're fine. If for some reason you're using higher concentration, and in our case, it'd be very few cases you would do that, then you do need to make sure that the concentration and the type of material you have isn't going to cause corrosion. For instance, with brass, you can get lead leaching out of them if you have too high of concentrations. But for us, that generally is not an issue. Orientation, I already mentioned that, making sure you're following the arrows that are on the piece of the check valve you have, making sure the flow is correct, and also with swing, making sure the orientation is correct on it. As far as sizing, again, almost any type of size of pipe is acceptable. If you do have problems with pressure drop, for instance, then you may need to be upsizing your check valves. But under normal conditions, any size of pipe we have will be fine. This is just an example of a foot valve, brass in this case, and you'll notice that it says where may be an issue with this product be used to convey or disperse water potable. It can only be used in certain states, and there's more details there. Most of your suppliers will give you this type of information especially when you tell them it's related to a water supply. I do want to talk a little bit about air gaps and where they make sense. See in this slide, you have 3 drains. They're all interconnected for the outflow. You have pesticide clean out drain, you have toilet drains, and you have a 3-bay sink drain. So everything flows fine long as everything is open. But if you get in a situation where you have a clog, say right in the main drain, and you have pesticides, again, toilet drain, and this 3-bay sink all connected together in the main drain, what happens is, for instance, from the pesticide drain, it's going to take the path of least resistance. So it's going to move backwards towards the toilet drain and the 3-bay sink. Then it will continue the path of least resistance, especially with the toilet. You're not going to give much movement up, but it's going to force everything back to that 3-bay sink. So what happens? Well, if you have an air gap, it can overflow. Is it a mess? Yeah, it's a mess. Maybe it smells. Yes, it may smell. But the thing is, it can be cleaned up. You're not forcing that product up into your 3-bay sink. If you have a closed system where you don't have that air gap, then there is a possibility that all of that is going to get forced up into your 3-bay sink. And if you have product in there or just a small amount of water, you may end up getting it in there and not realizing it. So it's much better in that type of situation to have an air gap. And this next slide shows you an example of an air gap on a 3-bay sink, where if you have a problem, you're going to get overflow onto your floor, but that can be cleaned up. If it was all connected and it forces up in there, you may not notice it right away, and you may contaminate product. The other issue that I see is floors that are not level or not sloped towards drain. The picture on your left there, well, you'll notice that a lot of cracks around the drain. Great place for material to collect. If you get anything coming back up through that drain, gets into those cracks, crevices, and it's a good harborage of pathogens, especially Listeria. Listeria is one of our big issues when we get into drains, because once you get it into the drain, it's next to impossible to get out. I know of one grower who had to jackhammer all their floors out and put new drains in because they could not get rid of the Listeria. Even with a new structure, you can have issues. On your right here, you'll notice cement floor, recently poured cement, good, great system for a drain, but when they poured the cement, there was one area that wasn't sloped properly, and you can see the water collecting on the floor. And the fact that they can drive through this, if they're bringing in, say, a tractor or wagon from outside, going through this, they may spread around the facility pathogens off the tires of those vehicles. So it's important, if you're putting in a new floor, cement floor, making sure that they get it poured correctly and sloped correctly. The other issue with floor drains is if you do not maintain them, you can end up with what you have on the left here. You have a backup, they're trying to get it cleaned out. What are they using? They're using a hose, but in this case is connected to a water supply on the top. They may get some backflow through that because there's no preventer on this. The other thing is that hose is getting contaminated with whatever is in that drain. And if they don't clean it and sanitize it properly, they can contaminate a lot of stuff. As you can see, that drain has obviously overflowed, and that's why they're trying to clean it out. So you should be servicing these drains weekly, cleaning them out, disinfecting the drains, and you should have open drains, as you can see here on the right. I've had the question recently about, well, should we even have a drain in a packing house? The answer is yes. You want to keep your floors as dry as possible. Again, great source for pathogens to grow on if you have standing water. So yes, you should have drains and floors, but making sure that they're sloped properly and maintained. So we're talking about air gaps. Here's a picture of a leafy green operation. They're doing spinach. They're using that blue lay flat hose there to put water into the tank. The unfortunate thing, they have that hose directly down into the product. They should have an air gap so that hose is above that tank, so it doesn't have a chance of being contaminated. So where should you have backflow prevention devices? on supply lines at individual buildings. In special situations that where is a potential for risk, especially chemical injections, you definitely should have backflow devices on those. Should have foot valves on your irrigation system, and again, using air gaps for places where you don't want to contaminate, for instance, a hose. And as I mentioned earlier, related to the pesticide, if you're filling a pesticide sprayer, making sure that hose isn't stuck down in the tank. Again, it's a great way to contaminate the hose. And also, if you don't have a backflow device, it's a great way to contaminate a well. As far as drains are concerned, consider what your product is, where that outflow is going to go to, and making sure it's plumbed properly. Again, use air gaps where it makes sense to use them. But what happens if you have a problem? What if you have to clean up a mess? You should be thinking about ahead of time how you're going to do it. Who is responsible? Developing a standard operating procedure of where your supplies are kept, who knows how to do it, who you should be calling, making sure everything is done properly, and everyone understanding that ahead of time. And if you need to be checking those and to make sure they are working, making sure the pressure is right on those. So checking with your irrigation person, checking with anyone that's doing your plumbing in your packing houses to make sure you know how to check those, or if they need to be inspected annually. Most of this presentation was put together by excuse me, by Chris Callahan from the University of Vermont. He's a agriculture engineer. In fact, one of the few agriculture engineers we have left in the Northeast and Mid-Atlantic. These are two of his websites, and his address is there, his email address. A lot of good information, not just on this, but a whole bunch of other subjects related to agriculture engineering. So if you're looking for information, this is a good source to go to. Last thing I'd like to mention, this is our website. You can see our address on top there, onfarmfoodsafety.rutgers.edu. We maintain this site. We have all the information on third-party audits. We have a whole section now on COVID-19 and all the documents related to that. And there's a lot of resource material. We also have things, for instance, on developing a recall plan for your operation. You all should have received by now a letter or an email related to vaccinations for COVID that was sent out on Monday. And I was on a call this morning, and there's been 107 farms that have signed up to have their workers vaccinated. They're using the Johnson & Johnson vaccination. Fill out that survey. It goes to the New Jersey Department of Ag. It's all New Jersey Department of Health. It all goes electronically. Then they will contact the Federal Qualified Health Center to call you and set up an appointment to vaccinate your workers. Whether they will come to your operation or whether you have to go to a centralized place depends on how many employees you have.